Morning, ma'am.
Good morning. Mag-start na lang ko, Albert, ha? Bisag ikaw lang. Ho kayong ihi sa ilaga diri nga room. Mag-start na lang ta, Albert. Anyway, this is recorded. So, makakita or gapon sila. Okay, so we will continue with solving problems involving so ganito, we are already done with problems with point charges, and then karon we will deal with continuous charge distribution. Okay, so bisag isa lang ka problem atong i-solve per topic, and then ako lang din siya i-problem set. Okay, para maka-practice mo. Alright? So, how about this problem? Find the electric field a distance z above the center of circular loop of radius r, which carries...
Ma'am, dili maklaro pa ang kuan, ma'am, presentation.
Okay. Paano ko na-share, I think. Sorry. Thank you for the notice. Okay, so find the electric field at distance z above the center of a circular loop of radius r, which carries a uniform line charge lambda. Okay, so here is a very rough image of the problem. So you have a circular loop, and then above the center, we have to measure the electric field at this point. So, nani siya sa center, sa circular path, sa circular loop. So, a distance z above the center. So, this is your point P here. So, dito magkuhag electric field. Okay. So, by symmetry, due to symmetry, unsa nga mga components ang mag-cancel out? So, for example, kini diri, magkuha kog point diri, magkuha kog point diri So, naani siya maghatag ni siya electric field equal to DE. And then, kini po siya, napod ni siya ma-contribute ng electric field equal to DE, for example. So, pareha sila og magnitude since pareha man sila og distance with respect to the point P. Okay? So, unsa nga component sa electric field ang mag-cancel out? So, nakaingani nga electric field. Ang mag-cancel out class kay kining x component. Okay? So, due to symmetry, the x components will cancel out. And ang mag-survive kay ang z components. So, kini siya no, nani siya z components that is going upward. Kini po siya na po siya z components going upward. So, the x components will cancel. Okay. So, bisag asa ka nga point diri as a circular loop magkuha, na siya kanang mura siya na siya symmetric nga counterpart such that mag-cancel out ang mga x components. Ang mahabilin na lang dayon kay mga z components. Okay? So, the electric field is equal to this one, 1 over 4 pi epsilon naught. You have the integral of dq, where dq is just equal to lambda dl. Okay? So, nakay 1/4 pi epsilon naught dq over r squared. And then, as you can see, your z component is adjacent to your angle theta. Asa ganyan ang theta, class? This is your theta. So, this is your theta. Okay? So this one is adjacent to your angle theta. So, the z component of the electric field is just equal to this multiplied by cosine theta. Okay? So, you have 1/4 pi epsilon naught dq over r squared. Ang iyang direction is, so iyang direction gani, z hat, no? Okay. Now, the electric field can be written as 1/4 pi epsilon naught, since dq, note that dq is just equal to lambda dl. Okay? Sakto ba ni? Nakadumdum mo, ani class, di ba? Ang charge per unit length is equal to q over l, the length. Okay? So, nakay dq is equal to lambda dl. So, you have integral of lambda dl over r squared. Okay. Shall we place here r hat sa r hat? But we know that this is along the z-axis. Okay. So your EZ, so the electric field along the z-axis is just equal to the electric field multiplied by cosine theta. Okay? So, kini siya nga electric field, i-multiplyan lang siya nato og cosine theta. So, you have, we can rewrite this as 1/4 pi epsilon naught integral of lambda dl over r squared. And then you have here cosine theta. Now, let us determine r squared. This is along the z-hat axis. Z-axis, okay? So, let us determine r squared and cosine theta. Okay, so from the figure, we can see that r squared, gani ang r squared, class? R is the distance from the point padulong sa, this is your source point, and then this one is your field point, okay? So, r is the distance from the source point towards the field point. Therefore, as you can see from the figure, this is actually equal to, kini siya, class, this is the radius. Radius man ni siya, no? This is the radius of the circular loop, and it is said, ang radius daw niya is equal to r. And then this one is z. So therefore, your r is equal to, or r squared is equal to r squared plus z squared. Sakto ba? By virtue of the Pythagorean theorem. And then your cosine theta is equal to, so ito ka. So ka adjacent side over the hypotenuse. So the adjacent side is z. The adjacent side to your angle theta is z. And then the hypotenuse is r. So therefore, your cosine theta is equal to z over r. Okay? So let us substitute it here sa atong expression sa electric field, and then we will do integration. So you have the electric field along the z-axis is equal to 1/4 pi epsilon naught. You have the integral of lambda dl over r squared. You have cosine theta. Your cosine theta is now so ito siya, z over r. Cosine theta is equal to z over r, and then you have z hat here. Okay, so you have 1 over 4 pi epsilon naught. So we have lambda z dl divided by your r squared is equal to, so na kay r cube, no? R cube, so you have r squared plus z squared raised to the power of 3 halves. Okay. Since your r is equal to the square root of r squared plus z squared, diba? So from here, your r, it is equal to the square root of r squared plus z squared. So you have r cubed is equal to this one, r squared plus z squared raised to the power of 3 halves. Napabatay nalimtan this one. So z hat. Now, take note that lambda, your z, your r are constants. So these are constants, meaning to say, we will just integrate this with respect to the length. And the length of the circular loop is from 0 to 2 pi r. So, ang iyang circumference kibali. So you have 1 over 4 pi. We forgot to include the integral sign. Okay, so again, since constant naman ni si lambda, si z, and then si r squared, pwede ni siya na to ipagawa sa integral sign. So you have lambda z over r squared plus z squared raised to the power of 3 halves integral of dl. Okay, so you have your z hat here. And then we will integrate this from 0 to 2 pi r since we have a circular loop. Okay, so you have 1 over 4 pi epsilon naught lambda z over r squared plus z squared raised to the power of 3 halves. And then this one, the integral of dl is L from 0 to 2 pi r, so you have 2 pi r. Okay, so I guess we can rewrite this one. Pwede na to i-cancel out ang pi o kining 2 diri but pwede ra gyapon to i-retain ang k. K is 1 over 4 pi epsilon naught. We have lambda 2 pi r, i-rewrite lang siya na to para tsada siya lang tawon. Divided by r squared plus z squared raised to the power of 3 halves z hat. Okay, so this is the electric field at the point a distance z above the center of a circular loop. Okay, do you have questions? Okay, so if you have problems like this, you can automatically use this equation to solve for the electric field. Okay, now let us try to have kini siya kay circular loop lang, no? Let us try to have a circular plane. So let us try to solve for the electric field for a circular plane, or we can call this a disk. So kanang siya CD. Ganina loop lang to siya, meaning to say walay kuan sa tunga, walay charge sa tunga. Okay? Mura lang siya wire nga gi-circular ang form, gi-loop ang form. This time, we will have a disk. Okay. So find, let me just write it. Electric field. A distance z from the center of a disk. Center. It's a flat circular disk. Of radius r. Okay. So this disk carries a uniform charge density equal to sigma. Okay, so this is a surface charge distribution. So kaganina we have dealt with a line charge distribution. So mo siya wire nga giloop. This time we'll have a disk. Okay. So kini siya nun ano siya ay charges here. Dili ni siya charges kas but it signifies anang solid ni siya diri, dili ni siya kuan hollow. Okay? So you have here a disk and then we want to know the electric field a distance z from the center of the disk. So this is your point P. Okay? Now, in order to solve this one, we should break the disk into rings of radius r. Okay, so break. What we will do is to break the disk into rings of radius r. So, ang disk class has a radius big R. And then, if you have to break the disk into rings, ang katong mga rings class kina siya radius R. So, kini si R mag-vary ang value. Okay, so the value of R varies depende kung asa ka magkuha og ring. So, syempre, kung duol-duol imo ang ring diri sa center, mas gamay ang value ni R. Kung nakadiri dapit sa may edge, then dako po ang value ni R. Okay, so R varies. Alright. So, ang ring class, na siya radius R, and then napod siya thickness nga dr. Thickness dr. Okay, so siguro ingani ang ring. So naamang gyapon siya thickness like this. Yang thickness kay dr. Sorry. Okay? So muna yang thickness dr and then yang radius with respect from the center of course is r. Okay? So, for this, nagihapoy mag-cancel out nga components, which is the x components again. Okay, so the horizontal components will cancel out due to symmetry. Okay, so the electric field, the x component of the electric field will cancel out due to symmetry. Okay, so E is equal to 1 over 4 pi epsilon naught. Same ra gyapon no? dq over r squared r hat. Okay. So here your dq, since we have a line charge where, sorry, it's a surface charge distribution. So your dq is equal to sigma dA. Okay, so kaganina, dq is equal to lambda dl. Now, since we have a surface charge distribution, our dq is equal to sigma times dA. Okay? And then, since x component, z components man ang mahabilin, where your z is adjacent to your angle theta, then the electric field class is the electric field along the z is equal to 1 over 4 pi epsilon naught integral of sigma dA over r squared, and then you have cosine theta, you have z hat. Okay? Now, what is your dA. What is dA, class? So what is your dA? Your dA is equal to, so ano siya pag-calculate? The circumference of this multiplied by the thickness. Ito ba? Ano ba ni siya ang area ani? Ang area ani, class, kay ang area aning mga rings is equal to 2 pi r multiplied by iyang thickness nga dr. So dA equals 2 pi r times dr. Kaya ba mo ani? If we integrate this one, actually this is pi r squared. Sakto ba? Integrating this, you will get pi r squared, which is the area of the circle. Okay, so you have 1 over 4 pi epsilon naught, and then you have the integral of sigma times your dA is equal to 2 pi r dr over r squared. What is r squared, by the way? So the same lagi hapon, no? So if this is r here, if this is r diri so this is z. Okay, so this is your r, the separation vector r. So from the source point towards the field point. So this is equal to the square root of r squared plus z squared. So isulat na to diri, class, ha. So dA equals 2 pi r dr, and then your separation vector r is square root of r squared plus z squared. And then your cosine theta, we need cosine theta. So your cosine theta, if this is theta, then your cosine theta is equal to z over the separation vector r, the magnitude of the separation vector r. Okay, so we can substitute all of this here. So you have z over r for the cosine theta, and then you have here r squared z hat. So you have 1 over 4 pi epsilon naught integral of sigma multiplied by 2 pi r dr. So you can insert z here over your r cube is r squared plus z squared raised to the power of 3 halves z hat. Now take note that we will be differentiating with respect to r. Okay? So sigma is constant. Z is also constant. So pwede na siya ito ipagawa sa integral sign. Sigma z, you have 2 pi sigma z, pagawas na to daan, over 4 pi epsilon naught. So what's inside the integral sign? Kay kini na lang r dr over r squared plus z squared. Okay, so what is the integral of this? Sa integral ani, class? Okay, so take note that from the table of integrals, so kini siya, class, nga mga solusyon, we're doing this provided nga wala pa ta kabalo og Gauss law. Okay, so later we will have Gauss law. Okay, nibalik man ta sa mga examples, mag-iyon na to ang concepts, and then here we are solving for problems. Okay, so kini siya nga mga solutions provided nga wala pa ta kabalo og Gauss law, but when we use Gauss law to solve this, this will become easier. Okay, so you have take note that from the table of integrals, the integral of r dr over r squared plus z squared raised to the power of 3/2 is equal to the negative of, sorry, so you have the negative of 1 over the square root of r squared plus z squared. Okay, so this is from the table of integrals. Therefore, so kini siya diri, no? Ito lang ning i-substitute here. And then we will integrate this from 0 to r. So this will be integrated from 0 to big R. Okay, so this is the radius of the disk. So you have 2 pi sigma z. Let me know kung natin nalimtan nga mga constants. 2 pi sigma z over 4 pi epsilon naught. And then you have negative 1 over the square root of r squared plus z squared integrated from 0 to r. Okay, so let us evaluate this one. So evaluating this, you have 2 pi sigma z, you have 4 pi epsilon naught, and then negative 1 over the square root of, ilisan lang nina to r diri o big R, r squared plus z squared, minus negative, so may siyang positive, minus negative 1 over the square root of 0 squared plus z squared. Okay? So, ito lang ni siyang i-rewrite. Sigma z over 4 pi epsilon naught. Kini siya is 1 over z squared. This is 1 over z. And then, balhin ni siya na to diri para nindot lang tawon. 1 over the square root of r squared plus z squared. Of course, you have z hat here. Okay?
Okay, ma'am.
So this is for a circular disk. Now, if r is much greater than z, so what if r is much greater than z? So unsa implication ani r much greater than z? So meaning to say, duol kaayo ang point nimo sa disk. Okay, so for example, na diri imong disk. If r is much greater than z, so dako kaayo ang z, so nara diri imong point P. Okay, nara siya duol sa disk. Dili ni siya sa sulod gyud sa disk la sa naa siya duol, dili na lang tayo bata. Duol lang siya sa disk. Okay? So, what will happen? So, kini siya, this will approach to 0. Ano man? 1 over the square root of r squared plus z squared will approach to 0. So, you have okay, so if r is much greater than z, then this factor 1 over the square root of r squared plus z squared approaches to 0. Okay, so implication. So this is for the case for an infinite plane. So muna siya infinite plane class. Infinite plane. Okay, so for the case of an infinite plane, you have 1 over 4 pi epsilon naught, 2 pi sigma z multiplied by 1 over z. So, kung wala ni siya nga factor, so ang mahabilin kay kanina lang. 1 over z. So, we can cancel out z. Okay? So, we can cancel out z for the plane. Dili na siya dependent sa z. So, you have, it will become 1 over 4 pi epsilon naught 2 pi sigma. Okay, so you have your z hat here. So provided nga z hat, this is actually the general equation class for an infinite plane. Provided nga kanaing ani iyang orientation. Pero kung like for example, imong plane kay naging ani, then diri imong point nga i-consider. So lahi man pud ang mag-cancel out. So ang z components ang mag-cancel out. So x hat pud diri okay? So for an infinite plane, this can be further canceled out kining 2 pi this one. So isulat na to ha. In general, for infinite plane, so the electric field is equal to sigma over 2 epsilon naught. So it is not dependent on z nor the length of the plane. Infinite man siya nga plane. So mag-cancel out ni si 2 pi o kini si 2 pi po sa ubos ang mahabilin kay sigma over epsilon naught. Okay? So again, z hat siya kung ing ato ang orientation sa imong plane, but if nagtakilid po siya, so lahi po ang iyang kuan class. Ang iyang direction. Okay? So this is for an infinite plane. So very simple la kayo. And then, kung ang z class is much greater than r, so layo kaayo ang imo ang point nga gina-consider. So kining imong infinite kining imo ang this diri kay mura lang ni siya point charge. Okay? So ang imo ang electric field kay mo reduce ra pud siya to that of a point charge. So if z is much greater than r, then the case will become like that of a point charge. Okay? Pero mag-binomial series expansion pa data. So if z is much greater than r, then you have 1 over the square root of r squared plus z squared is equal to 1 over z multiplied by 1 over the square root of r squared plus z squared. Kibali, gipagawas lang na ko ang c class, gipagawas lang na to ang z. So, gi-factor out ni siya na to yung diri sa sulod no na kay r squared plus z squared, and then divide both sides by, i-divide nimo siya og z squared. So, naa kay, sa denominator ni siya, 1 over z squared, you have r squared, wait sa. So, ang gibuhat ani kay gipagawas ang z squared. Okay? So, para mapagawas ni si z squared diri sa square root sign, ito ba ni? Okay. So, you have this one. Kung ibalik ni siya nako diri class, ibalik ni siya nako diri, this will become r squared minus z squared lang gihapon. Sakto ba? So 1 over z multiplied by 1 over the square root of r squared over z squared minus z squared over z squared is just equal to this one. So gipagawas lang na to ang z para we will have binomial expansion. So you have 1 over z This can be further simplified here. Square root of r squared over z squared minus 1. Okay, so this is minus 1. Ay, anong minus ni class? This is plus. Plus. Okay, so plus ni siya diri, plus. So you have here 1 ha, nakay 1 diri ah. Okay, so you can rewrite this. Ang imo ang 1 over the square root of r squared plus z squared. This is equal to this one. 1 over z. And then you have r squared plus z squared plus 1 raised to the power of minus 1 half. So, ibalhin lang ni siya nato sa numerator. That is why you have here a power of minus 1 half. Okay, so we can do binomial series expansion. I do not know if this is making sense. Okay. So, this is approximately, kini siya class nga factor. This is approximately equal to 1 over z. So, again, ang binomial series expansion or Taylor series, mangguro yapon. So, familiar sa inyo class, katong Taylor series. Naman sa inyong math, no? So, you have 1 over z multiplied by 1 minus 1 half multiplied by r squared over z squared. Okay. So, muna siya ang equivalent ani nga factor. Okay, so you can review Taylor series. Nganong naingani ni siya class? Or binomial series expansion. Okay? Now, the term in the bracket will become, so balik ta diri, kini siya no? Muna siya nga bracket. So this term here, if z is much greater than r, then this will become 2 pi sigma z over 4 pi epsilon naught, 1 over z minus katong nakuha na to sa Taylor series expansion. Okay? So, atong i-substitute to diri aha. Copy lang ni siya na to class and then i-substitute here the, so you have e sub z equals 1 over 4 pi epsilon naught. And then you have 2 pi sigma z multiplied by 1 over z minus, sa ganito, 1 over z minus ba to? 1 half. You have r squared over z squared. Let me just, okay, so 1 over z minus 1 half r squared over z cubed ay. Over z cubed. So, gipasulod na to ang 1 over z. Z cubed ni siya. Okay? So, we can, this will be cancelled out, no? Ano siya? Minus. So, we will be left with 1 over 4 pi epsilon naught, 2 pi sigma z. And then from here, you have negative times negative. You have positive 1 half r squared over z cubed. Okay? So, cancel this out. Kini isa diri. So, duhan lang nabilin nga z. So, pwede makancel out kas 2. Okay? So, we have here 1 over 4 pi epsilon naught pi sigma r squared over z squared. Sakto ba? 1/4 pi epsilon naught pi sigma r squared over z squared. And take note that kini si sigma r squared, sigma pi r squared class. So, ganyan yung pi r squared. Pi r squared where pi r squared is, what is pi r squared? This is the area of the whole disk. Area of the disk. Okay? And then you have here sigma multiplied by the area. So, sigma multiplied by the area of the whole disk, that is actually the total charge Q. Okay, so Q, the total charge Q is equal to sigma multiplied by the area of the whole disk. Okay, so we can rewrite this as 1/4 pi epsilon naught Q. Kini siya, no? The whole numerator is actually Q over Z squared. Z hat.
Ma'am, na ako'y pangutana, ma'am.
Yes, yes.
Ngano ganing nawala na ang sa negative 1 half, ma'am ba? Nawala ang negative niya, ma'am? Pag-rewrite ni mo diri sa kwan.
This one?
Oo.
Okay. So, since we have a negative sign here, so negative multiplied by the quantity inside the bracket. So, that is why na minus po, nawala po ni si 1 over z. So, you have 1 over z minus 1 over z. Tapos, kini siya, imo maning i-multiply po daanin niya. So, you have positive 1/2 r squared.
Ay,
CQ.
multiply first man day. Oh, thank you, ma'am.
Okay. So, any questions? Any other questions? So, unsa nahitabo class, if z is much greater than the radius r, so mura siya point charge, no? Again, if lahi pod ang orientation sa imo ang disk, like for example, diri siya, diri. So, ang mag-cancel out kay katong z component, ang mabilin kay ang x component. So, dili po ni siya z diri, x po ni siya, o x po guro ni siya diri. Yes, it's x po diri. Okay? So, let's have one, I think we will have one more example na lang sa divergence Gauss law. Okay, so how about this one, this problem? Naansira na ba ni siya nato, class? Are you familiar with this problem? Suppose the electric field in some region is found to be E equals KR cubed. So we are given with an electric field equal to KR cubed. Masig naansira na ni nato. In spherical coordinates, where K is constant. Okay. So first is find the charge density. Find the charge density. And then find the total charge contained in a sphere. Find the total charge contained in a sphere of radius r, centered at the origin. Okay, so we are given with this electric field in some region. And this is in spherical coordinates. So how to find the charge density? Okay, so unsa man itong nahibalaan, class? What do we know? This is from Ito na ning problems involving divergence and curl of electrostatic fields. Field lines, flux, and Gauss law. Okay, so what we know is this. Recall. Okay, so recall that, so ganun ni siyang equation class. This is Gauss law in differential form. Is this Gauss law in differential form? Kadumdum pa mo? Okay, so to find the charge density, since we are given with the electric field, we just have to manipulate this equation. So you have rho is equal to epsilon naught, a constant, multiplied by the divergence of the electric field. Okay, so since this is in spherical coordinates, what is the divergence of the electric field? So your electric field is along the the radial direction. Okay, so it has a radial component only. So what is the divergence of the electric field? Okay. So, ang sige, ito i-form sa inyo ang divergence in spherical coordinates. You have 1 over r. 1 over r ba to or 1 over r squared? 1 over r squared multiplied by the partial derivative with respect to r of r squared times v sub r or e sub r, the radial component of the electric field. So you have k r cubed. Okay? So muna siya ang divergence of the electric field. So since radial component naman sa klasa, isa ra ka component ang nadiri. Okay? So you have 1 over r squared, partial derivative with respect to r of r squared, k r cubed. All right. So how do we derive this one? So you have rho is equal to epsilon naught. You have 1 over r squared. So ito, partial derivative of kr cubed times r squared, no? So naakay kr to the fifth. Sakto ba? Kr to the fifth. So you have, pagawas lang na to ang k. Kay constant naman na si k. K epsilon naught 1 over r squared. Pila man ni siya class? 5 k r to the fourth.
Oh, ma'am, 4.
Oh?
Yes.
Okay. So k epsilon naught 1 over r squared 5 kr to the fourth. We can cancel out this one. So we have k epsilon naught. Ay, no, nani k diri. Ipagawas mo din na tong k. So k epsilon naught, you have 5r squared. What man lang taon class? This is 5 epsilon naught kr squared. Okay raman na. So this is your charge density, the charge density. Okay, and then how about the total charge? Now, for the total charge, find the total charge. So ano to pag find sa total charge? Since we have unsay na nahibalaan na to class. So you have rho na natay value sa rho. And for spherical coordinates, we can actually get the total charge or the enclosed charge to be equal to the integral of rho times d tau. Okay? So we are given with atong nakuha ang rho. And then for spherical coordinates, what is d tau? So you have 5 epsilon naught kr squared. And then your d tau is, so itong d tau, recall that d tau in you have kasi maka-recall class. Muna siya pinakasayon ang d tau. R squared sine theta d theta or dr d phi.
DRD fee di theta mga.
Okay. So, pwede na gihapon na to isulat as that. Pareha gihapon to siya. Pero mas nindot siya lang tawon kung ingani, no? So, dr d theta d phi. So, you have r squared sine theta dr d theta d phi. Okay, so how do we integrate this one? So this is triple integration. Ipagawas na to ni daan yung mga constant. 5 epsilon naught k. And then you have r squared times r squared. So you have r to the fourth dr from 0 to r, big R. Ano ba kay provisions today? Okay, find the total charge contained in a sphere of radius r centered at the origin. Okay, so you have 0 to r. And then you have sine theta d theta. This is integrated from 0 to, ang theta class, sa ganun siya, pi ra siya taman. And then your d phi from 0 to 2 pi. So actually, we know the integral of this already. This is equal to 4 pi. Sakto ba? 4 pi, no? So this is 2 pi multiplied by 2. Okay? So, ang ato na lang evaluate kay kin na lang siya. So, this is 2. Ini siya diri kay 2 pi. This is actually the solid angle. Solid angle ang tawag ani sa higher nga electromagnet. Okay. So, you have r to the fourth dr. So, integral of this is 1 over 5. 1 over 4. Sakto ba, class? 1 over 5 or 1 over 4? Hello, Philippines?
Dapit ma'am.
Which one? What is the integral of this?
1. R5 over 5.
Okay, very good. So you have 5 epsilon naught k so to r5 over 5 from 0 to r multiplied by 4 pi. Okay. So you have here, pwede na to i-cancel daan si 5 epsilon naught 4 pi epsilon naught. Sorry, 4 pi epsilon naught k, and then you have r to the 5. So, hugaw kayo itong solusyon. So, how do we write this one para tsada siya lang taon? 4 pi epsilon naught k r to the 5. So, ganun siya. This is your Q enclosed. Okay. So, 4 pi epsilon naught k r to the 5. Napay other way to solve this one. Or you can solve it using this. Integral of E dot dA. So this is Gauss law in integral form. Integral of E dot dA is equal to Q enclosed over epsilon naught. Okay, so from here, your Q enclosed is equal to epsilon naught multiplied by the integral of E dot dA. Okay, so substituting, yatagan man taog ko ano, E. So E is KR cube, R hat. And then your DA, since R hat man ang direction sa ato ang electric field, so kato na pong radial nga direction sa ato ang DA. So unsa man ang radial direction sa ato ang DA class?
2 phi RDR.
You have this one. Na kay DA, no? Ang DA ni mo kay na siya yung ani nga component. D theta d phi r hat plus dr d phi theta hat plus dr d phi d theta phi hat. Okay, so kini siya nga component class. What is this? Ang d theta ni mo kay so ang gani? So you have r d theta and then so you have r squared sine theta. So kining naani siya dapat, no? D theta d phi. R squared sine theta d theta d phi. Okay. So kini siya di ay r squared sine theta d theta d phi, kini siya kay RDR. Okay, so di lang na to i-figure out. Okay, so this one, r squared sine theta d phi, integrating this with respect to r from 0 to r. And then, kinipod siya, theta from 0 to 0 to pi, and then d phi is from 0 to 2 pi. So we will get the same. You have epsilon naught integral of r to the 5th. Gihapon atong makuha class. dr. Ay, walay dr. Wait sa. So here, so you have epsilon naught kr cube r squared sine theta d phi, since kini siya di ay your r is equal to r. So surface integration wherein your r is equal to big R. So pwede ra siya na to i-diretso og substitute r to the 5th, and then we will integrate only this one. Surface integral man siya. Sine theta d theta from 0 to pi, and then d phi from 0 to 2 pi. Pareha ra ba ito makuha? Okay, so you have 4 pi here. Same ra ito makuha. 4 pi epsilon naught multiplied by k r to the 5th. This is big R. Since for this, we are integrating sa surface man, no? We are integrating sa surface. So kung naakay sphere of radius r, so sa surface class, bisag asa ka magkuhag infinitesimal nga area diri sa surface, ang iya ang radius kay r gina siya. Okay? So radius is constant for this. Nakuha ninyo? Okay, so this equation or this solution involves volume integration, and then this one, it involves surface integration. Okay? So it's 8:28. Yes? Do you have questions?
None so far pa, ma'am.
Okay, so in the next meeting class, we will have 2 problems involving Gauss law. And then we will proceed to our conceptual discussion on, wala pa tayo example sa potential, no? So Gauss law, example sa Gauss law, tapos example sa potential, and then we will proceed to the next subtopic. Okay, so medyo inay gyud ato ang discussion sa electromag. So chapter 2 pa lang ta class, hapit na mahuman ang SEM. Alright, so sige lang, baala na. So see you. Ano sa to magkita na po daan ni. Next week is palaro week. I do not know, wala man po ka ng memo pa for suspension. So if ever walay suspension, then pwede ra siguro ta makaklase ana. But if mag-memo sila og suspension, then we will meet on next week after the palaro week. Okay, so
Okay, ma'am.
see you next time.
Excuse, ma'am.
Kanang
Katong first bitaw nga discussion ni ma'am. Pwede kanang makakita mi sa video ato, ma'am. Ay, sa recorded video.
asa ato, John Paul? Wala pa na ako na-send ang mga videos.
Kung ano rin mong na-send, ma'am, kanang notes.
Okay. So, pila ka videos ang wala pa na ako na-send. I think na-upload naman ko to sa YouTube. Wala pa din ako na-send ang link.
Isa ra mong guro.
Okay. So, katong problems gihapon, like kini
Yes, ma'am.
ini ang kuan. Okay, so let me check.
Ma'am, pwede i-appeal nga video, ma'am. I-upload ron.
Ha?
Ay, kani nga recorded video mo ba? Pwede ni ma-upload ron. Wala mo gud ko kasulod sa kato nga, ma'am. Kay wala ko'y load.
Karon, pwede ra karon siguro, pero unya padapit naman ko'y klase taod-taod. So, kung buhaton ani kay